Okay, so as you can see, we're about to do a notes template. You can choose how you'd like to do it. Do you want to write it in your math notebook? Do you want to print out this paper and write it with me? Or do you want to just do it digitally on Cami? Either way, I'm going to be using a lot of colors if you want to get your colors ready. Okay, so looking at the title here, this is the triangle congruence properties. Again, this is a Math 1 topic that we were supposed to learn last year. I'm spending a week on reviewing triangles in case during the time of COVID, it didn't stick as much as it needed to. So we're starting up here with this concept of even though triangles have 6 pairs of things, they have 1, 2, 1, 2, 1, 2, 3 sides and 3 angles. So 3 pairs of sides, 3 pairs of angles. That's 6 pairs of items, but we don't need all 6 to be congruent in order to prove congruency properties. We only need at least 3. We need at least 3 things to be corresponding and congruent in order for the triangles to be congruent. And then these are the 3 things that we need. These are all the different postulates, the different properties we're going to learn right now. So the first one is side, side, side. That means that the triangle has 3 pairs of congruent sides. If we know that the triangles have these, then we can say that they're congruent. So does it guarantee congruence? Yes. So let's go ahead and write this down and we're going to highlight as we go. So for example, I'm going to start with side AB. I'm making that a little red side. For that side AB, we're looking at the other triangle to see which one is corresponding to AB. Notice that if I took this triangle and I rotated it, would that triangle land on the other triangle? No, I don't think so, because this side has 2 marks and this side has 2 marks. And this side that I just highlighted in red has 1 mark, and this side has 1 mark. So these 2 corresponding parts would not land on each other if I just rotated it. What if I moved it a little bit and then reflected it? Yes. So this has to be done 2 transformations in order to move this triangle onto this one. It has to be slightly rotated and then reflected onto the other one. Either way, this has 1 mark, this has 1 mark. These are my corresponding parts. Now notice that B is in between the 1 and the 3 slash. So over here, M is in between the 1 and the 3 slash. So that means that the corner or vertex B is corresponding to the corner or vertex M. Okay, well, what about A? A is in between the 1 and the 2 slash. So looking over here in between the 1 and the 2 slash is the L. My corresponding corner or vertex on that one is L. And that just leaves C and K as corresponding. What do I mean corresponding? I mean in the same position. Okay, so which other sides? Let's go ahead and use green for this one. This 2 slash is equal to this 2 slash. And finally, this 3 slash, I'm going to use pink, is equal to this 3 slash. Okay, now I've got my triangles all the way highlighted. I'm ready to go write down the parts that guarantee the congruence. So for example, starting with red, I would say that side AB is congruent to side. Now check it out. I went yellow, blue. So I'm going to go yellow, blue for this one, ML. Side AB is congruent to side ML. Red side done. Next side I'm going to do is the green side. I would say side AC is congruent. So notice I went blue, orange, is congruent to side blue, orange, LK. Finally, let's do the pink side. I would say that side BC is congruent to side. Now notice I went yellow, orange, so I'm going to go yellow, orange, MK. I have to put the corresponding parts in the correct corresponding places. Now, what is the reason for all of these? The reason is that they were given. Where were they given? Here in the image. These marks were given to us, telling us that these were congruent. Now notice, this is a side, this is a side, this is a side. I have 3 pairs of sides that are congruent. Therefore, I can state that the triangles are congruent. So my final statement would be triangle ABC is congruent to triangle. Now hang on a second. ABC goes blue, gold, orange. So I have to go blue, gold, orange when I state this triangle name, LMK. Let me know. Okay. And then my reason for this is going to be by side, side, side. Okay. So we're stating what parts we have given in the image, and then the triangle congruency statement by what postulate. All right, let's go to the next one. Let's get those colors ready. Notice that this one's giving us an angle this time. Side, angle, side. And so 2 pairs of congruent sides and 1 pair of congruent angles, the angles are between the pair of sides for this one. Side, angle, side. So here I go. I'm going to start with C matches Z, is corresponding to Z. Why? Because those both have the equivalent, they have the marker showing that they're equal. Now I'm going to follow out the 1/ side to the B, and I'm going to follow out the 1/ side to the Y. Those are my corresponding parts on that one. Finally, that leaves me A and X as corresponding. Okay, going to do the sides now. We have this 1/ side, I'm using red. And then we have this 2/ side, I'm using green. And now we're ready to go do our statements. So starting with the green side, doesn't really matter which one I'm doing, but I'm going to start with green. I'm going to say that side AC is congruent to side. Now pause for a minute. AC is stated as blue, yellow. So blue, yellow. XZ. AC is congruent to side XZ. That's my green side. Next, I'm doing my red side. BC, actually, I'm going to do the angle in the middle. BC is congruent. Now notice I went orange, yellow, so I have to go orange, yellow, so that's YZ. Now in the middle is my angle. So I'm going to say angle C is congruent to angle Z. Now what is my reason for all of these? My reason is that they were given in the picture here as congruent. We were told that this side, and this angle. So I have a side, I have an angle, I have a side, and the angle is in between the 2 sides. So I can say triangle ABC is congruent to triangle. Pause for a minute and see if you can come up with the letters here by side, angle, side. Now notice that you went blue, orange, yellow, so you have to go blue, orange, yellow. How'd you do? All right, the next one is angle, side, angle. So this time we're being given 2 angles and 1 side in between. Notice that the in between is there. The side is in between the pairs of angles. The angle was in between the pairs of sides. That's important. Okay, so let's go with first highlighting the corners. I've got this 1 slasher, right? It's 1 mark on that angle. B is going to be corresponding to angle Y. And then I've got this 2 mark for A, which means that it's corresponding to my X. And not that it matters, but my Z then corresponds to my C. And then I'm going to go look at the side. I'm going to use green. This 1 side that they gave me is corresponding to this 1 side right here. They are congruent. Okay, so I'm going angle, side, angle this time. So here I go. Angle A is congruent to angle X. And then I'm going to do the in between the side. Side AB is congruent to side. Notice I went blue, orange, so I have to go blue, orange, XY. And finally, angle B is congruent to angle Y. There's my orange angle. And so because I have an angle, a side, and an angle, ASA, I have enough for congruency. What's my reason for this? They were given in the image. And I can now say that triangle ABC is congruent to triangle. Pause the video, see if you can get the letters on your own. And this is going to be by angle, side angle. Okay, how'd you do? ABC is blue, orange, yellow. So blue, orange, yellow is XYZ. All right, last one. Last postulate that we're going to do is the angle, angle, side. And so this time I've got two angles again and a side. Hey, I had two angles here and a side. So what's the difference? Look at the difference. Notice that here the side is in between. Here the side is not. It is not the side in between. It is this side over here. So that is the difference between AAS and ASA. So here's my one side. I'm going to use red. And then here's one angle. Angle Y has one slash. Angle A has one slash. Angle B has two slashes. Angle Z, those are corresponding. And finally, C is corresponding to X. Okay, so let's do the angles first. I'm going to go angle A, orange angle, is congruent to angle Y. And then I'm going to go angle B is congruent to angle Z. And then I've got an angle, Now I need my side. I'm going to say side AC is congruent to side XY. Now notice, I went AC, I went orange, blue, and I just accidentally said it backwards. I said blue, orange, so I need to change this to YX. Be careful. If you go orange, blue here, you have to go orange, blue here. I almost left that. Okay, what's the reason for these? These were given. And now we can say that triangle ABC is congruent to triangle. So I went orange, yellow, blue. So I'm going to go orange, yellow, blue, YZX. What's our reason? By angle, angle, side. You can also say SAA, side angle, angle. Okay, so these are examples of mini proofs of how we prove that triangles are congruent. You state the pieces that were given to you, then you state the triangle congruency statement by what postulate. Okay, there are two things that don't work. So we want to make sure you understand that these things do not work. Side, side angle, or angle, side, side. If I have two sides and one angle, it's not enough because look, this side and this side match, this side and this side, the angle matches, but oh my gosh, do those look congruent? Heck no. So it is not enough to have two sides. So you might go, okay, AB is congruent to ED and AC is congruent to EF, those were given in the picture, and angle B is congruent to angle D. But these three statements are a side, and an angle, SSA, and we know no, they are not guaranteed congruent because more than one triangle is possible. We would just need more info in order to prove these as congruent. This is not enough information to prove they're congruent. We would need more info. Okay, what about AAA? Look at these three angles are the same and these three angles are the same, but they are definitely two different sized triangles. So you'd be like, okay, angle C is congruent to angle Q. Angle A is congruent to angle P. And angle B is congruent to angle R. And even though I have those three angles, I'm like, wait, AAA is not enough. So we know that these are not enough for congruency, but ding, 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 ding. It is going to be this new thing called similar that we learn next week. So just a little hint, this happens later. It means similar, just not congruent. So keep in mind, these are our no's and these are our yeses, okay? Now I'm going to flip over to the next side, which gives us a little bit more information about triangle congruence. Once we find 3 corresponding pairs of congruent parts to prove 2 triangles are congruent, then we know all 6 corresponding parts of the congruent triangles are congruent. Okay, what was that called in our study guide? CPCTC, congruent parts of congruent triangles are congruent, okay? Now, using SAS from the triangle congruence properties, what do I mean? I mean, we see here that this 1 slash is equal to this 1 slash, this 2 slash side is equal to this 2 slash side, and we have an angle. So it's a side angle side congruence. So we can say side AC is congruent to XZ. We can say that angle C is congruent to angle Z. We can say that this side BC is congruent to YZ. So the triangles are congruent, right? Since the triangles are guaranteed to be congruent, we can now guarantee that angle A is also congruent to angle X. We know this now. And we can say that angle B is congruent to angle Y. We know this now. And we can say that also side AB is now congruent to XY. We know this now because we know that if 3 parts were congruent, the triangles are congruent, so all 6 parts are congruent. So there's 2 ways that we use this. In the study guide, they taught you CPCTC, congruent parts of congruent triangles are congruent, or there's another little notation that people use, and that's congruent triangles have congruent parts. And so I want to write this out and then give you the full notation. Congruent triangles have congruent parts. And what does that notation look like? It would go like this. Congruent triangles have congruent parts. So you can either use this as your reason, or you can say CPCTC, congruent parts of congruent triangles are congruent. These mean the same thing. They're just 2 different notations to say if the triangles are congruent, all the parts are congruent. Okay, one last thing we need to go over down here, a couple of the other stuff we're going to need for our proofs. A few additional things that come up when trying to prove triangles. Sometimes 2 triangles can share a side. Even if they're not marked, these pieces can be guaranteed congruent because anything is congruent to itself, right? In math, we call this the reflexive property. Sometimes in order to be clear about which specific angle we're referring to, we need to use a 3-letter name instead of the single letter. This is necessary when you have more than one angle with the same vertex. Okay, so what do I mean? I mean, if you're talking about 2 triangles here, and I say A, B, C, D, E, if I was asking you about angle A and angle E, does everybody understand that angle A is clearly identified because it's the only part of this corner, and angle E is congruent to angle A, but there's only 1 letter needed. But what if I was talking about angle C? You're like, which angle C? There's 2 of them that have the same vertex. So here I would have to say angle ACB is congruent to ECD. I would need to use a 3-letter name. Sometimes we need to use 3-letter names instead of a single letter. This is necessary when you have more than 1 angle with the same vertex. So the middle one is an example where I'd have to use a 3-letter name instead of a single letter name in my proof. Okay. Example, is triangle MAH congruent to TAH? There are 2 pieces marked. We know that MA is congruent to TA. So we would say, given that was given to us in the picture. And then here we can say that angle MAH is also congruent to TAH. To say angle A is congruent to angle A would not be correct because they're the same letter. They're sharing the same, they're not the exact same piece. There's actually two angles with an A in the middle. So only two congruent corresponding parts is not enough information to guarantee congruent triangles. We need one more piece, but we do know another piece. We know that AH is congruent to AH, to itself. This middle piece right here is the same shared side. Isn't that same side going to be the same length? It's the same, it's itself. So AH is congruent to AH by the reflexive property. So we can conclude that triangle MAH is congruent to triangle TAH by side angle side. What are my sides again? I've got this bottom side that was given. I've got this right angle that was marked. And then we found out about the yellow reflexive side. That's my side angle side. This is called a paragraph proof when we write it in sort of a paragraph form. And then the ones that we were doing before are 2-column proofs. What do the 2 columns consist of? Your reasons go on the left. Your justifications like given and SAS go on the right. So just way down here at the very, very bottom, I want you to write a little note. 2-column proofs have 2 sides to a table where your statements, like things that you were given, go on the left, and then your reasons or justifications go on the right. And this is going to be the format we use to go through some proofs on Thursday, Friday. Okay, that's it for your notes today. How'd you do?